So last time we have seen how to insert in the binary tree. So we take the first node, let's say we put the value in the root, and if this is the first node, we return it. But if it is not the first node, then we create a temporary variable current which will move forward, which will initially be assigned to root. And then if the value which is entered is greater than the current value, we go on the right side. And if it is less, we go on the left side. On the right side, if right side is not there, we immediately enter it and return it. If right side is there, then we move the pointer current to the current dot right, and then we again go to the while loop and follow the same procedure. So that way we create the tree. Now let's create one tree here, and we'll see how it looks, and then we'll go further to do more manipulation. So first I will insert, for example, 6, then I will insert 4. Okay, next I will insert 2. Next I will insert 5. Next I will insert 1. Next I will insert 3. Next I will insert 8. Next I will insert 7. Next I will insert 9. And then I will insert 10. So this is the tree I will create right now. So let's run it and see how it goes. Okay, so we have this B. So the root is having 6 value. So let's build it in the diagram also. So we have 6 here. Then we have on the left side, we have 4 and 8. Okay, 4 on the left side, right side we have 8. So let's build. First step, insert 6. Then I insert 4. Since 4 is smaller than 6, it will go on the left side and it will be created here. Okay, then I insert 2. 2 will be going to the left side of the 4 because 2 is smaller than the 4. So 2 will come here. Then 5. So 5 will less than 6, so it will go to this side, and it is greater than 4, so it will go here. 5 will go here. Then I insert 1. 1 will travel till 2, and it's less than 1, less than 2, so 1 will be inserted here. Next is 3. It will go left side, then left side, then greater than 2, so it will go 3 here. Then we put 8. 8 is greater than 6, so it will go here. Then we put 7. 7 is greater than 6, it will go here. 7 is less than 8, so it will go here. Then we have 9. 9 is greater than 6, it will go right side. 9 is greater than 8, it will go on the right side of 8. Then we insert 10. 10 is greater than 6, greater than 8, greater than 9, so it will be on the right side of 9. So this is how we have. Let's see the tree here. So here we have 6, 4 and 8 are the child. So the 6 is there, 4 and 8 are the child. If I go on the left side, we have 2 and 5. We have 2 and 5 as a child. And then if I go to the left side of 2, we have 1 and 3. We have 1 and 3. And if we go to the 5, it does not have anything left and right. As we see here, we don't have child of 5. Next, we will go to the right side of the 6, that is 8. 8 has 7 and 9 child, so we have 7 and 9 child of 8. Here we have 7 and 9. And the left side of 7 is null, right side is null. right side of 9 is right side of the 9 is another node, left side is null, and right side is 10, as we see here. So we are building a tree which is same in this one. Now we have built a tree. Now what we are trying to do, next thing which we will do is this one. Let's see. So this is the function we use to insert the elements in the tree, in the binary search tree. Now the second function is we need to find the value in the tree. So write down the function this.find equal to value. So only thing which we will do in this find is if we found that number, we will return true, and if we don't find, then we return false. So it's not that we return the value, because we already know what we are trying to find. We're trying to find the value, let's say some value. So we cannot return value because we are trying to find that value. So either it is true or not. So in reality, the word is if this value exists in the tree or not. So find is not the better way of this one. We can say exists. Maybe we can say exists. So whether this value exists in the tree. You can put find also, but find is not the perfect word for this one. Okay, let's put exist, and we will see if value exists in the tree or not. So either we have to return true or false. If we don't have the root, that means the tree is empty. So what should I do? I should return true or false. I don't have the root. That means no, it's empty. That means value does not exist in the tree. So what should I do? Shall I return true or false? My voice is low. Is everybody feeling my voice low? Let me check. Okay, Kate is saying no. Okay. Tom, can you check your speaker? Okay, return false. Kate has answer return false. Since root is, there is nothing in the tree, and we ask some value, that means that value does not exist in the tree. So I'll say return false. Now let's move down the tree. And now if the tree exists, then we have to create this current temporary variable, and we have to go through left or right side. Okay, so let's create the temporary variable. So here, create a temporary variable pointing to root. Okay, now what I will do, I will put something in this, in the while loop. Right now I'm not putting it. Right now let's make it true for now. But true is not the real thing. We have to change it to something which I will tell you in a minute. Or maybe we can say if current exists. That means if tree exists, then loop it. Okay, so this is the something we'll use it. Now let's say tree exists, and I'm trying to search this value. So what I will do, I will try to see. Let's say I'm passing b.exist. Okay, I'm passing some value. So let's take a value of 10 kind of thing. I'm trying to see if 10 exists in the tree. Okay, so I will check. So right now the current is pointing to the root. Root is nothing but the first value, that is the 6th number. This number. So current is at this level. Okay. So now what I will check? I will check if this 10 is greater than 6 or smaller than 6. If 10 is greater than 6, whether I will go on the right side or left side. If 10 is greater than 6, I will go on the left side or right side? Right side. Agreed. So here, this 10 is nothing but the value, this value. And this 6 is nothing but the current dot value, because we are saving in the current dot value. So if I want to compare 6, I will take current dot value. And if I want to compare 10, I will use this value which I am passing it. So here I will check if value which is I am passing, that is 10, is greater than current dot value. So if it is greater than the current value, I will say go to right side. Okay. I will write else if value is less than current dot value, then I will say go to left side. And if it is same, that means we found that value. If both are same, that means we found it and we can return that value. Return true. If both are same, that means we found and we return that true in this case. Otherwise, we will not return true. Okay, so this is true. Now, I will check value is greater than current dot value. As we see in this example, value that is 10 is greater than 6. So we will go to the right side of this one. So here, once we go right or left side, we have to check. Once we go to right side or left side, we have to check if that side exists. Okay, so we are going to the right side of the 6. Let's take example once again. We are going to the right side of the 6. Right side of 6 is this one. Right side exists or not? Yes, it exists. Right side exists. So there will be two cases. If right side does not exist, let's assume right side does not exist. If not current dot right. So that means if I make a tree like another tree 6 and it does not have any right side. Okay, so it's on the right side it is empty, but on the left side it is 4. And I'm trying to see if 10 exists or not. So it will check whether 10 is greater than 6. Yes, so it has to go to the right side. But right side does not have any child. Then what we will do, we will return false, because 10 should exist on the right side of the 6, and now right side of 6 is not there, so we will return false in this case. Okay, so if right side does not exist, we have to immediately return false. Similarly, if we go on the left side, and if left side does not exist, then we will return false. But what if right side exists? If right side exists, then we have to change the current to current dot right. That means we are moving our pointer from this point to this point. Then again we go to the while loop. Okay, and but when on the left side, if we found the left side, then we will say current equal to current dot left, and then we will go to the while loop again and we will loop through it. And if we don't get this case return true, everything other thing is false. And once we are out of the while loop and we have not returned, that means it is false, and we will return false in the end. Now go through this process again and see. So I will pass here value as 10, which will check with the 6 number, this 6 number, and value 10 is greater than 6. So it should go to the right side and it will check if current dot right exists or not. Let's take 6 dot right exists. Since 6 dot exists, so current will move to this point, current dot right. So current was initially here, now current moved to here. Once current move here, we will go again in the while loop and we will check if the value is greater than the current dot value. What value we are checking? 10 number. Whether 10 is greater than 8 or no. 10 is greater than 8. Since 10 is greater than 8, so we will go to the right side again and we will see if right side exists or not, this one. Since this exists on the right side, that means we will move the current to the current dot right. So now C will point to this C, this 9 number. And we'll go to the while loop again. Here again I will check if the value, that is 10, is greater than 9 or not? Yes, value is greater than 9. So we will go again to the right side and we will move the current to here. So we are moving the current to current dot right. Now we will check this 10 is greater than 10? No. 10 is less than 10? No. 10 is equal to 10? Yes. So we will return true in this case. Okay. So we are getting true in this case. Let's take another example. I am trying to search 12. Okay. So I am trying to search 12. So what will happen now? Let's delete this one. Okay. So I am trying to search 12. Initially the current will be here at this one. Since 12 is greater than 6, so we will move to the right side and the current will move to here. Since 12 is greater than 8, we will go to the right side and current will change to here 9. And again I'll change 12 is greater than 9, yes. So it will go to the right side and it will go here, current will point to this one. Then again I'll check 12 is greater than 10, yes. So it should go to the right side, but right side does not exist. That means we will return false. This is example of 12. Let's take example of 7. I'll delete the one. Okay, let's delete this one. So now let's take example of 7. So I will make the current to this one. Since 7 is greater than 6, so we'll move the pointer to here. Now 7 is less than 8, so we will go to the left side. So our current will go to here, and then we'll check 7 is equal to 7, we'll return 2. That is how we are going to do, and this is the code which I have written it. So before I go further, just write down this exist code from here till here, and then I'll go to another function. So this is done. This function is done to find whether the value exists or not. Is this clear? This method is clear? So no need to by heart now. Once the idea is clear, after the class you do this 10 times. Write down this function 10 times to by heart the things. But at least you get the idea how we are traveling down and we're changing the current to the new current. Okay, is it done? Okay, so now next thing which we have to do here is we have to traverse. If you remember, we were traversing here in the tree. We were traversing with the two ways. One is traverse breadth first or traverse depth first. Okay, so we will be doing similar kind of traversing in this tree. So here if you see we have two types of traverse. One is called breadth first and then the depth first. But in case of binary search tree we have four types of traversing. So let's write down the four types of traversing. One is called breadth first. So I'll say this dot BFS. So this is the first one. Second is called depth first search, but here it is called the pre-order. So this is a pre-order. Next is uh, also depth first search DFS, but here it is called post order. Okay, and the fourth type is this dot DFS in order. Okay, so there are four types of search. Write down these four functions, empty functions. We will fill it in 1 minute. Okay, I'll give you 1 minute to fill this one. Okay, so if we talk about the breadth first search, it is similar to what we did in the tree kind of the case. How we traveled it here is the similar in the binary search tree. So only difference is that here we have number of children, but here we have only two children left and right. So we have to take care of only two children in binary search tree, whereas in tree we are taking the care of multiple children by pushing like this. Okay, so this is the difference. So I will write down the meaning. Breadth first search is similar to breadth first search in tree. Let's talk about what is in the pre-order. So in the pre-order, parent is in the pre-order. Let me write on the pre-order. In pre-order, traversal, in the pre-order, parent is visited first, then left child, and then right child. Okay, so this is how we traverse. So let's try to go through these two in the image, and then we'll go through these two also in a minute. Okay, so let me show how it will travel in this case. So if we talk about the breadth first search, it is same as tree. First this will be traverse, then this line, then this line, and then this line. So the result will be 6, 4, 8, 2, 5, 7, 9, 1, 3, and 10. So this is how we go with the breadth first search. Let's go to another one now. The breadth first is same, so I just showed you how it goes. Now let's go to the pre-order. Here parent is visited first, and then left child, and then right child. So let's go to here. So here in this case, if we are doing depth first search with the pre-order, so what it says, parent is visited first, then left child, then right child. So it will go, parent is this one, 6 number. So 6 will come first. Then it will go to the left side first. And once we go to left side, parent is 4. So we'll take the 4. Then we again go to the left side first. We'll not touch the right side. We'll go to the left side first. Then we'll take 2. Then again we go to the left side. And once we get left side, we take this value 1. And we try to go to left side, and there's no left side there. So we will go to the right side of the 2. Right side of the 2 is 3. The next will be the 3. After we fill right side of 3, 2 is already there, 4 is already there, and we have taken left side of the 4, but now we have to take the right side of the 4, that is 5 number. Then again we go to the 6 top. Left side is now already filled. Now we go to the top. Top as the right side. Right side first we take the parent, that is 8 will come. Then we go to the left side of the parent, that is 7. And we don't have anything, so we'll go to the right side of the 8, that is 9. And we don't have left side of the 9, we go to the right side of the 9, that is 10. So this is the pre-order. We go like this. So let me draw one more thing here, how it goes. So if I want to draw, it will start with here. It will go here. Then it will go here. Let me take different color. It will go here. Then 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 it will go here. After this, it will go to here 8 number. 8 number to 7 number. After 7 number, it will go to 9 number and then 10 number. So it will go first here, second here, third here, fourth here, fifth here, sixth here, seventh here, eighth here, ninth here, and 10th here. So this is how pre-order traverses. Okay, so let's take one more row. Okay, let's delete Let's delete some of the things. Okay, so we went to the depth first pre-order. That means it will take parent first, then it go to left child, and then go to right child. That is how it travel here. Let's see how. Let me write down these values also. Okay, 648. So here it will be 648 257 9 1 3 10. This is how it will traverse. Now let's take this one. It will be 6421 6421. Then comes 3. Then comes 5. Then comes 8, 7, 9, 10. This is how we go to the pre-order. Now let's go to the post order. Okay. So in the post order, let me write in the post order. Left child is visited first, then right child, and then parent. So here parent is first, left is second, right is third. So parent, left, right. Parent, then left side, then right side. Here it is left, then right, then parent. Okay, this is how it travels. We will go to the diagram in a minute. Let's try to see what we get in the in order. Okay, let me write down the in order also right now. In order, what we do, what is the way? So here, first left child is taken care of. Then, then it's, you can call it as parent is taken care of, and then right child is taken care of. So it's left child, parent, right child. Okay, something like that. So let's go through this, walk through this in the image, and then we'll walk through this one also. Okay, so let's try to see this one. Okay, post order. Post order is first we go to the left child, then we go to the right child, then we go to the parent. So this is the pre-order, post order. Let's take one more. And here I will write on the in order. Okay, so let's go to the post order. What is post order? Post order is first left child, then right child, then parent. So initially we start with the root, but since root is a parent, we go to the left side. We'll not take the root first because we have to take first the left child. 4 is also the parent. We'll take the left of the 4. Then we'll take the left of the 2. And then we got the 1. So the first point will be, starting point will be this one. This is the first point. So we have to go with the first left, then right, then parent. Okay. First left, then right, then parent. So left side is done for this one. Now we'll go to the parent, we'll go take the right side. We'll not take the parent now because the rule is first left side, then right side, then parent. So one point is done, one number is done. Then we'll go to 3. So after 1, it will go to the right side, that is 3. This is 2 number point. So second point we will take is 3. Okay. Left and right are done. Then we have to go to parent. So that means we have to take 2. This is third number point. Now 2 is taken. Now we'll go to the parent. Parent we will not take. Parent will come in the last. So after 2, parent is 4, but we'll not take the parent. We'll take the right side of the parent. That is 5 number. So this is number 4. So after 2, we will go to the 5. Okay, let's go to the 5. Okay, next is we have to take the parent. Now left, right are done. We have to take the parent. That is 4 number. So next point is 5 here. So after 4, we will go here. Now left side of 6 is done. Shall I take 6 now or shall I go to the right side? No, the answer is go to the right side. I'm not talking about exact number. So we have to go to the right side.
Right.
Yeah. So we cannot take 6 number. First we have to go to the right side. So right side also, I cannot take this because this is a parent of something. This is not the end or something. So this is also parent of something. Since it has left and right side, we'll go to the left side first. That means 7. So the next point will be 7. So after this, 6 number point is here. So after this, we will go to here. Now 7 is done. So left side of 8 is done. Now we have to go to the right side of the 8. Right side of 8 is 9. But since 9 is also parent of something, so we cannot take parent unless we finish left and right side. So we will take the left side of 9, which is nothing, but we'll take the right side of 10 and right side of the 9, which is 10. So we have to take 10 here first. So after 7, our point will be this one. 7th number point is this one. Go here. Since right side of 9 is done, now we have to go to parent. That is parent is 9. So after 10, we will go to this point. This is our 8 number point. Now parent is done. Left right side is done. We'll go to parent of this one. That is, this is the 9 number point. So we will take 8. These points are where I am traveling. First I am traveling this 2, 3, 4, 5, 6, and these are the real values which I am putting it here. Okay, try to understand what I am putting. This 1, 2, 3 is where I am traveling, and these are the real numbers. After 8, left and right side of 8 is done. So ultimately we have to go to parent of the 8. So this is our 10 number point, and after 9 we will go here. So after 8 we will go to 6. So this is the diagram for the DFS where we go left, right, and parent. Left, right, parent. Left, right, parent. Left, right, then parent, like this. So if we want to build here, it will be 1, 3, 2, 5, 4, 7, 10, 9, 8, 6. This is how we will go through post order. Post order goes in this way, LRP. Pre-order goes in this way, PLR, parent, left and right. So this is parent, left, then right, parent, left, right, parent, left, right, like that. Here I will write down parent, then left, then right. Okay, now let's go to the last in order, where we go left child, then parent, and then right child. Okay, so let's try to do this with example. Okay. So here this is in order, and this is of the format left side, then parent, then right side. So first we'll go to the root. Since we cannot take root is a parent of something, so we cannot take root. We have to go to left side first. So we'll go to the 4 number. Since 4 is also parent of something, we have to go to left side, that is 2 number. Since 2 is also parent of something, so we have to go to 1 number. So this is first starting point. So output will be 1 as a first starting point. Then if you go this follow, we have to go to parent, not the right. So I cannot go 3 first. I have to go to parent. So parent of 1 is 2. So I'll write down 2 here. So after 1, it will go to 2. After parent, we have to go to the right side. So right side is 3 number. So after 2, we'll go to 3. Okay. So now left side of 4 is done. Now will I go to 5 number or 4 number? 4 number. Right. Because left side is done, then we have to go to parent. So after 3, 4 will come. Now after parent, we have to go to right side. So right side is 5 number. After 5, left side of 6 is done. Now whether I should go 6 number or I should go to this one. Yes, so we have to go to 6 number because after left is done, we have to go to parent. 6 number. So after 6 number, left side is done, parent is done. So right side of 6 number will start. So when I go to right side, this is a parent. We cannot go parent first. We have to go to the left side of parent. So that means after 6, we have to go to 7, left side. Since left side is done, we cannot go to the right side. We have to go to first parent. So it is 8 number. And parent is done, then we have to go to right side. But right side is also parent. Okay, so we have to go to left side of the parent, which is nothing. Since left side, we have to go to left side of the parent. It is nothing. So we have to go to parent again. So after 8 number, parent will come, that is 9. And after parent, we have to go to the right side. So right side will be after 9, it will be 10. So after 8 and then 9 and the 10. So it will go to first left, parent, right. Left, parent, right. Left side, parent, right side. Left side, parent, right side. Left side, parent, right side. Like that. This is called in order. So the ultimate order for this one will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So just write down this explanation in 2 minutes and then we will fill the functions of each one. So this BFS is similar to breadth first, which we did here. So just we will revise this part again for the breadth first. And once I will explain you pre-order, this post-order and in-order are the similar. So we don't have to work more on this two. We have to work only on the pre-order. Once you know the pre-order, then these two are same. Only there is difference in one line of the code. Okay, so I'll give you 2 minutes to finish this explanation. Write on this explanation. Okay, let's start now filling the explanation. So when you go in interview, generally they will not ask this how you are doing. This we are doing for the purpose of learning. But when you go for interview, they will ask how it traverses. Okay, so how it traverses. That is how most of the interview is taken care of. Few interview they may ask you the code, how to write the code. Okay, that is only 10%, but in 90% they will only ask the explanation how you traverse in order, how you traverse in post order, pre order. So try to understand this diagram and again, and it is better to do code also because 10% people may ask you the code also, how to write the breadth first, how to write TFS, post order, pre order, or in order. So let's go walk through this again. Okay, let's go to the breadth first. So this is the breadth first. As we have done, if you remember what we have done here, we created this data, which is the output, and we started with the root node, and we put it in the temporary array, and we take out from the temporary array, and we add the children in the temporary array. Like this, we were doing it. Same thing we will do here, and we'll walk through, and we'll see how to do things. So the first thing is we need to create a data which will be, I will output it. So this is the output array. Since it is output, it will return data. So in the end, I have to return the data. Similarly, if we don't have root, that means we cannot process anything. So we will just return this data. So if nothing is in the root, I have to return empty data. We don't need anything to output it. Okay, next we have to assign this root to the temporary array, and then we have to move this current node to down and down. So let's make this temporary one here. So this is always create a temporary variable which will go through the tree. So this will go through the tree. I also need a temporary array which will be filled in each session, which will be filled with the child in each session. Okay, so these are the initiation of the variables. So I will create one more called as constant temporary, which is also an array. And we'll take from this current, we will put it in the temporary array, and then we will move through it as we did before. Okay, so let me put it in the diagram. So this is the data, which is ultimately output. We need the temporary array, which will be filled one by one. So what we have to do first, in the breadth first, we have to initially take the first root value and put it in the temporary one. So what I will say, temporary dot push current, this current, I will put this in the temporary. So initially this temporary will get the 6th number node. Okay, we get the 6th number node in the temporary. Now we have to only go through this temporary and see if something is there in this temporary. If there is something in the temporary, then we will take it out, manipulate it, put it in the final output. This is the output. Okay, so idea is first we will put in this temporary and take one by one and manipulate it and put it in the output. That's what we are trying to do it. So initially when I put temporary dot push, I put the current, that is 6th number, in the temporary. Now 6th number is initially gone to temporary. Now I will go through this temporary array and I will see what to do. So since we have to go through the temporary only, we will check if temporary dot length is greater than 0, then only we'll go. If it is not greater than 0, that means everything is exhausted and we don't have to move further. So right now, first time we already put here in the temporary this current value, that is this root 1, 6 number. Now 6 number will take this 6 number out. So to take the 6 number out, take the number out from the front. We have to take from the front. So we'll take the number 6. If we have more variable, we have to take the first number, that is this one. So since this is array, we have to take the first number out. What shall I use here? I want to take one out from the temporary array, which is in the beginning, that is this beginning. If we have more here, then also I have to take from the beginning. It is shift, so we have to take from the shift. Okay, so shift is right. So what I will do here, I will say current. We will update the current with the new value in the temp. Initially I took current and put it in the temp, but now that was only the initialization. Here we have to update the current with the what we are taking out from the temporary. So we are taking first one from the temporary, that is temp dot shift. Since I did shift 1, that means node is taken out of temp variable, temp array. Since I use shift, that means 6 will be gone. This 6 will be gone since I am taking it into the current. So current will be now 6. Okay, so we are taking out of the 6. So initially in our case, we are taking example 6. So now current is 6 and temp has become empty. Okay, here in this line of the code. Because we are taking 6 out, put it in this variable, and temp is now empty. First thing which we have to do, since we are taking out the 6, we will put it in the output. Output is nothing but this data. So take the value and put it in output. So I will say data dot push equal to current dot value. We will put the value, not the whole node, because output should be a simple number, not the node kind of thing. So first thing we are taking out in the and put it here. So we are taking this 6 out, put it here. This is the output. Now what we have to do? We have to check if current has left or not. If current has left, current dot left is there, then we will put this left in the temporary array. So I will say if current dot left is there, temp dot push equal to current dot left. And then I will also check if current dot right is there, I will put temp dot push to current dot right. So what I am doing, I am checking if we have child, we are putting in the temp variable. Similarly, what we did in the traverse one, if we were having child, we were putting the child, whole child in the temporary array. But in current case, we are not putting the whole, we are taking only left and right. We don't have to put all. We don't have all. We have left and right. So we'll check if left is there, put it in the temp. And if right is there, put it in the temp. So in our case, we'll check whether 6 has left or no. 6 has left, that is 4. So what I will do, I will put 4 in the temporary array. And 6 has also right. So I will put 8 also in the temporary array. This is gone. So now 4 and 8 are there in the temporary array. Okay, 6 is gone here in the one. And this while loop first part is done. Now we'll go to the while loop again and we'll see if temporary array has length greater than 0 or not. Since we have two elements, that means it is greater than 0. That means we have to go inside the array. Here again we will take the current equal to temp.shift. That means we have to take this 4 number and put it in the current value. So this 4 number will go here. So we'll take this 4 number to the current one. Since we have taken the 4 and we have shifted it, that means this is deleted from here. And we have taken it here. And first step is, since we have taken out this 4, we will put 4 in the output. So output will get 4. And then we'll see if 4 has left or right child. 4 has left side 2 and right side 5. So we will push these two inside the temp array. So I'll put 2 here and 5 here in the temp array. So temp array is 8, 2 and 5. That's it. We have done this. Now we will check again with the temp array as something. It has 8 number here. Since it has 8 number, we'll take out this 8 number, put this 8 number here, and we will also put this 8 number in the output. And then we'll check whether 8 has any child or not. So 8 has these two child. So we will put these two child in the array. After 5, we will put 7 and 9. So if you see till 3 number, we have the 6 number, then we have traveled to 4 and 8. And then we have to take the 2 number. 2 number will follow same thing. 2 will give me, so what we'll do, we'll take the 2 out, we'll put it 2 here, we'll put the 2 here, we'll check if 2 has child or not, 2 has child, so we'll put 1 here, and we'll put 3 here. And then 2 is done. Then we'll take the 5 number. We'll put the 5 number here. We'll put the 5 number here. We'll check if 5 has child, no child, so we don't do anything. 5 is gone. Then we'll take 7 number. We'll put 7 number here. We'll put 7 number here output. And we will check 7 has child or not, no child, so we don't do anything. Then we'll take 9 number from here. From 9 number, we'll put 9 number here. We'll put 9 number here in the current one. We'll check if 9 has child, it has right child, we'll put 10 number here in the temp array. And 9 number is gone. Then we'll put 1 here. Then we'll put 3 here. Then we'll put 10 here. So we are traversing breadthwise. And this is the code which we do it. So if current has child, push them in temp array. So once we are done with this while loop, in the end we'll get the return data which will return, which will be in this format. Okay. Before we go to the pre-order, just write down this. It is similar what we did before, and hope it is clear. If you are not clear, you can watch video again to understand what I am explaining it again. Okay, I did it already also, and this is the way we are doing it. So write down this one and go through it video again and again. If you don't understand it, only do the breadth first search now. I'll give you 5 minutes. Okay, if it's not done, you can do it later. So let's quickly complete all these three. So these three are similar only, once we do first, other two are similar. So here also we have to output, like here we did output of data. So same thing with output here data. So let me make data. And we have to return data. So now we will create one temporary function here, which we will call again and again recursively, and that's the reason we need to create a function. So function will be traverse. We will traversing, and here we will push some node. Initially it will be root node, but then we will be updating this with the new node every time. And we'll call this initially with the root node. Not node this dot root. So initially we'll call this function with the root, whatever we have in the root. And then we will traverse the root and we will try to update the data as soon as we traverse it. Okay, let's try to go through inside this function and see what we have to write it. So what we did, we created an output variable, which we outputted, and we created that inside a function, which is a recursively we will call again and again, and I will update the data as we traverse the node, all the tree, as we traverse all the tree. So see what we have to do. So this is the pre-order. Let's see what is pre-order. Pre-order means we have to take the parent, then left, and then right. So parent means nothing but whatever node we have passed, that is called the parent initially. So this node when it comes, it is a parent initially when it comes. So what we have to do, we have to put this parent inside the output. So I will say data.push parent. Parent means whatever the node is coming is a parent right now. So I'll say node.value. So if we are passing this, our example, so 6 is the parent one, it will go inside the data. So the first item to go inside the data is 6 number. Then what I will do, I will check. Then we have to go to the left side. So I'll check if node dot left, if whatever node we have passed, if it has left side, then we will traverse that left side. So I will call traverse function again with the node dot left. Then we have to go to the right side. So I will say if node dot right exists, traverse node dot right. So what will happen in our case? 6 will go here. This 6 is in the first time 6 will go. So data will get first element as a 6. Okay, so data will be equal to 6. Then I will check if 6 has left node. 6 has left node. Does 6 has left node? Do 6 has left node? Yes. What is it? 4. What is it? 4. So 6 has 4 number. Since 6 has 4 number, I will pass that 4 number inside the node dot left. So node dot left will go to the 4 here. I will not touch the right now, but because we have called the traverse first with the 4 number, So we are not going to the right first. We are still at this point. So we are passing 4. And since 4 is passed, so traverse is called with the 4 number. Then we have to push that 4 number in the data. So the data will be now 6 and 4. After 4, I will check if 4 has child or not, left node or not. Does 4 has left node? Yes, 4 has left node. Here it should come 2. Okay, so 4 has left node, and that left node is nothing but the 2 number. So then I will pass the left node. Then I will pass this 2 number in the traverse. The 2 number will again go here. Since 2 number will go here, we will push that 2 number here. So data will be 6, 4, 2. Okay, so data will be 6, 4, 2. So after once we reach here 2, we will see whether 2 has left node or not. Does 2 have left node? So this is a 2 has left node. Yes, 2 has left node also. That is nothing but the 1. So we will pass 1 in the traverse function again. And since we call traverse function again, so it will push the 1 number here in the data. So the data will now be 6, 4, 2, 1. After 1, we are still in the traverse function with the 1. We'll check whether 1 has a left node or not. 1 does not have left node. Okay, since 1 does not have left node, we'll check the right node of the 1. Right? Does 1 has right node? No. So right node, right also we don't have it. So we will go. So the left node of all this number 6, 4, 2, 1 is exhausted. Now we have to go after 1. We have to go to parent and see whether parent. So left side is done. So we have to go to parent of the 1, that is 2 number, and we have to see whether 2 number has right node or not, because we have to check first left node and then right node. So left and right of 1 is done. So we have to go to here and we have to check whether 2 has right node or not. Whether 2 has right node or no. Yes. So 2 has right node, and the right node of the 2 is 3. So we will pass 3 here in the traverse function. That means 3 has to be inserted in the data. So the new data will be 6, 4, 2, 1, and then 3 will be added here. And since 3 is added here, then we will go to the left side of the 3 and right side of the 3. Left side of the 3 nothing, right side is nothing. So we are done with this process. Then we'll go to the right side of the 4, because left side of the 4 is done. Now we have to go to the right side of the 4. Right side of the 4 is what? 5. So we have to put 5 here in the right side. And 5 will go in the traverse function. Since 5 will go into traverse function, it will first put in the data. So the data will be 6, 4, 2, 1, 3, and then 5 will come here. After I put 5, I will check left side. After I put 5 here, I will check left side of the 5 and right side of the 5. Left side of the 5 is nothing, right side of the 5 is nothing. So we are done with the 5. So after 5 is done, we will go to the top level of the 4, that is 6. 6 left side is completely done. Then we will go to the right side of the 6. Right side of the 6 means we will take 8. So next element which will go is 8. So once I put 8 in this traverse mode, it will be directly added in the data. So the new data will be 6, 4, 2, 1, 3, 5, and then 8 will be inserted because we have inserted 8 in the traverse function. So as soon as I put 8, it will be inserted in the data as I have it added here. Then we will check the left side of the 8 and right side of the 8. Left side of the 8 is 7. So we will pass this 7 in the traverse function. As soon as I pass this 7 in the traverse function, it will be pushed into the data. So the new data will be, it will be same this plus we will add 7. And 7 will be added on the left side since it was in the left side. And once I add 7 here in the data, we will check the left side of the 7, right side of the 7. Then no left side of the 7, no right side of the 7. Since both are not there, we will go to the right side of the 8. Right side of the 8 will pass right side of the 8 here, that is 9. As soon as I pass 9 here, it will be added in the data and we will get 9 here. And once we get 9 here, 9 will be pushed here in the data and we'll go to the left side of the 9 and right side of the 9. Left side of the 9 is not there, so we'll go to the right side of the 9. Right side of the 9 is 10, which will be added here. And then 10 does not have left side and right side, and we are done with this process. So this function will be done. And once we have everything done, we don't have anything to call. So ultimately we will return the data here back. That is this final version, which is similar to what we found it here. So no need to write down this example which I have written, which this is only for explanation. Don't write it down. You can watch the video again to understand it. But write down these 3 lines here in this function and complete this function. So I'll give you 2 minutes to complete this function. So next, these 2 functions we will do copy paste and we will manipulate a little bit. So write down this function and then these 2 will be very quick. Is it done? Okay, so remember, if I want to do parent, I will use the data.push and I will insert the value in the parent in the output. So P means I put this one. L means if left node exists, I will traverse a node with the left side. And R means right side exists and we traverse the node, traverse the function with the right node. Since it is PLR, so we put the parent line, left side, right side. Let's try to fill this post order. So initially I will create the this dot data, data, constant data equal to empty array, which is the output. And I'll return this also, data in the end. And I will create the same function here, traverse function, and I will also traverse with the root. Now, here it is LRP. So L means we have to put the left side first in the traverse. Then it is saying right side. That means we have to put right side here in this one. And then we have to do parent. That means this line should be added here. And this function is done. With this function, we have PLR, that means P, L, and R. Here we have LRP, that is left, right, and the parent. So parent will come here. Let's copy this function again here in the last one. But here it is LPR. So left side, then we have to put parent. Parent means we have to put this line in the between. And then the right side. So this is called left side. P is nothing but this. And the right is this. So all three are same, but the order of calling the parent left and right is different. So here in the pre-order, we have PLR. In the post order, we have LRP, left, right, and parent. Left, right, and parent. And in order, we have left, parent, and right, LPR. And everything will follow in place. So just follow this LRP or LPR and everything will be okay. So just finish these two functions and then we'll run this function and see if we're getting this order or not. Okay, is it done? If it is not done, you can do later. Let's run it and see how it goes. Okay, so let me first call this function, and then we will see example one by one. So we'll run this. Okay, so I created the binary search tree which has 6, 4, 8, and 7, 9, 10. Left side we have 4, 2, 5, 2 as 1 and 3. So this is what we created here in this tree, and this is same thing is here. Now I will try to run each one and see how it goes. So let's run first BFS. So I'll say b.bfs. So you see answer is coming 64825791310. That is 64825791310. So we get the exact similar answer what we expected. Let's try to run the second function. b.dfs preorder. So preorder is 64213587910. 64213587910. So this is also working as expected. So let's do the post order. So post order is 132.547.10.986, 132.547.10.986. It is also same. And then is in order, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like here. So we have completed all the 4 types of traversal method in the binary search. Any questions?